Hello, everybody. Hope you're having a good Sunday. For some reason, it feels like my microphone is way far away. Hopefully, it's still in a good spot and you can hear me all right. Let me know if you cannot, and we'll get things started here in just a moment. Had a week or two off. Um, Last weekend, it was kind of unavoidable. It was very warm, and we did not have any air conditioning because our unit had broken. And we didn't realize it until we had regular service on it. And yeah, so we have a brand new one now, and it's working great. And then, of course, after we get it installed, it's no longer warm because that's how weather goes here. But we're going to get started, I think, in a few moments. We left our Survivors clone game in a spot where we needed to kind of level up the architecture. We'd gotten a lot of leverage out of LDTK and being able to define the game world with that tool. But for the type of game that we want, the enemies in the game will not be spawned on startup. They are on entering the level. They'll be spawned dynamically as time proceeds, which is what we had originally before we started working with the editor. But then there were a lot of nice things in the editor we wanted to take advantage of, so we kind of turned off the dynamic spawning system. And I'd like to get back to that. I have an idea. Maybe we'll see if it works. But I'm not certain yet whether Bevy has the tools I need to implement that idea, or whether we're going to have to do something more complicated. So I've been poking around in the documentation before we started, trying to see if there's, I don't know, an easy way to figure this out. So, and hopefully something that's not too tedious. But if that is the case, if it is tedious, then we'll just deal with it and we'll do the best that we can. Okay, so let's get started. Okay. I also considered, and maybe we'll do this in a future stream. There's this interesting blog series I found called Building Berkeley DB. And I thought it might be interesting to learn a little bit more about databases. I don't think we'll do this today, but let's keep this in our back pocket to do in a future stream. They've got 4 posts already. A lot of it, unfortunately, is about, they say ABI compatible. There's some stuff in there about exposing an API that is the same as the Berkeley DB one, and it's partly so you can test it against existing tests. But that would be a challenge if we are trying to implement this in something other than a language that compiles to machine code. And even then, it might be challenging if we decided to do it from Rust, we might have to have a big extern-C section. Remains to be seen whether this will be a wise thing to do or whether we can get around it. But I thought this might be interesting to look at later. There's byte diagrams, which I love. I ironically or unironically love. I don't know. In one job, I spent a lot of time thinking about network protocols, and like they're all the stuff in the RFCs is these, this many bytes wide, and these are the offsets after, and it's But like looking at this, I can see this would be really fun to do in Rust. It'd be fun to do in Erlang or Elixir because of binary pattern matching. And yeah, it would be neat to learn about how Berkeley DB works. So we may come back to this in a future stream. In the meantime, we're working on this. Let's look at our to-do. So this is what I was talking about a moment ago. We have the spawn behavior right now is, let me get LDTK running. The spawn behavior right now is just static. We have all of these entities in there. And yeah, they start a little ways from the player. But having them all spawned at the beginning makes for a very uninteresting gameplay and reduced flexibility. So if we had to spawn all of them, we'd basically just have a massive wave, and there would be no possibility for the player to be able to recover from mistakes in the early part of the game. The length of the game would be really short because you'd be dying or you'd be killing all the enemies right away. And that's just not fun. So so I think that what I'd like to do is let's here, let's just, okay, I don't want to select all those. I would like to just select no. I would like to just select the entities. Okay. And let's just actually delete everything, and we'll go ahead and put the player back in the center. Let's see, what was the width of this layer, or this level? I forget. Oh, well, it's 1600 by 1200 pixels, so that's 100 by 75. So, okay, so if we go back here and we put the player back in the world, we want to go at like 50 and 37, something like that. Okay, let's put the player back in the world. And now I do want to have entities in here, but I'm just going to put them in a very far away corner, one right next to the other. And my idea, I'm not sure if it's going to work, but my idea is that we can use these as prototypes of enemies to spawn, and we'll change how they're loaded from LDTK such that they'll get loaded with a different marker component. It says it's like an enemy prototype or something, and then they will be made invisible. And because they don't have the enemy component on them, they won't chase the player. They won't be active, you know. And we can basically we can move them outside the world, first of all, and they won't have any behavior on them. And since they're outside the world, they can't collide with anything. And then when we go to spawn, we'll use some information here. Let's see if we can make... I would love to make like an associative structure. All right, well let's do an array of strings. This is enemy types. Okay, and then how do you do this? Fine. Okay, array of string. So we could like zip this information together with how many of each we want to spawn. Let's see. Enemy types, and let's make a new one, which is a enemy count. Enemy counts. And it doesn't say what the format of that is. Okay, so this is just assigning the custom field or setting them up. Okay, here we go. So enemy types. Oh, you can add them. Yeah. Okay. So we're gonna say ghost. And this is a little bit janky, but and let's do bat next, and spider. Come on, and cyclops, and crab, because the crab is the hardest one. Okay, and then let's spawn 50. No, let's spawn 50 ghosts. And let's spawn 50 bats. And let's do the same on spiders. Let's do 10 cyclops and 5 crabs. Okay, this is what I've been trying to get to last time, or multiple previous things. I think if we can get to this data inside Bevy, and we can treat these as prototypes of enemies, and then when we spawn them based on this level data that we just set, we can pull the information from, say, like this, the health, the speed, all this stuff, and then apply that to the newly spawned enemy. I think that feels reasonable. So let me save this, and let's see. I want to get rid of single layer mode. There we go. And it doesn't really matter where these guys are, because we're just going to remove them or make them invisible immediately. Alternately, what we could do is leave the leave the components that are related to the essence of the enemy, and remove their world position stuff. So like remove their transform. Potentially, I don't think we want to remove the sprite stuff, because we'll want to copy that. But yeah, it's not clear exactly how we'll accomplish this yet. But I think that this is the right direction to go. And then we can do the same if we make another level that's like got different enemies in it or something. We can make a level with all wizards. I don't know. We've got like also other characters we can pull in here. Wizards and rats and slimes. Yeah. Okay. So now that we've got that saved, let's go back to our code. And let's look at the enemies. Oh, and I didn't update my... I do this... I'm sorry, I forgot to do this before the stream. I usually do this so we can get some decent size. Okay, that's going to be better. not too big. Okay, so let's look at. Okay, so we did just like looping over the names of the entities. Um, so the sprite sheet bundle is going to have a transform in it, right? Um, I think what we want to do I think we want to change this. So we're going to make a new marker component. And this is going to be enemy prototype or something like that. Right? And then let's just rename this to enemy prototype bundle. And then we'll replace this with enemy prototype. And then there's not, because I think I do a quick find all references on this. Yeah, so only things with the enemy component will chase the player. And then on these other things, you know, we only care about the collisions of things tagged enemy or keep them inside the walls. And maybe there's a different version of Sprite sheet bundle. Because if we don't need these, I don't know if this is going to make Bevy blow up. That's the part that I'm not sure about. But we could bring this bundle down to just the Texture Atlas sprite and a handle to the Texture Atlas. Potentially, if it doesn't require this flag on it. Let's have a quick look at the this derive macro for LDTK entity. We could potentially get away from doing this, and although it's probably the easiest way, and we could do the more manual way, because we have from entity instance on all of these things. Yeah, let's look at what they say about that derive. So they don't say that much. Okay. Okay. Where's the actual trait for those? All right. Okay. I think it's not. I'm actually kind of annoyed that they don't have more documentation here. The thing is, it's probably, yeah, it's in a separate crate. Okay. I'm not sure what all of these tags mean. Um, okay. So they are implementing this LDTK entity trait for the struct. Let's see what they do, the sprite sheet bundle. Okay, so that has to be tagged on something that is sprite sheet bundle. You can't just tag it on anything you want. What would be interesting to find out is, let's see, first of all, where's that? They implement the, right, okay, so the prelude, they implement this. What do those field constructors do? Field constructions. Okay, so they're pushing these extra derives on there. So we're looking for the sprite sheet bundle. Yeah, so expand sprite sheet bundle attribute. How are they actually accomplishing this? So, okay, so that's just checking that it's got the right type on the field. Okay, and this is, what is this, nested or? Okay, so this is, you can specify everything, I guess. But we're not doing that. Okay, so it says sprite sheet bundle from entity info. And that's taking the entity instance, tileset definition, texture atlases. And those texture atlases are passed in, like all this stuff. Okay. I wonder if we can use because we do this, you know, from entity instance. So let's go to this. Okay, so this takes an entity instance. We could potentially do something like this. But it's not giving everything here. In that from. So that's maybe not the right way to go. What if we do... right, so why don't we do... we're going to make a... clean up enemy prototypes. We'll just call it that. I don't have a better word for it right now, but yeah. And then we'll make this system down here, and let's do it above our spawn thing that we have commented out. So this is going to be clean up enemy prototypes. And what I want to do is we're going to have a query which is going to be basically we want to remove some components from them. Or the alternative is move it outside the level and hide it. But we're going to need something here, and we need added of enemy prototype. And there's maybe what we do, maybe it's just entity, and then we have commands for that. And I'm missing a bracket. That's why it looked weird. Okay. Been a while since I've done this, so if you see something that I'm doing wrong, let me know. Okay, so what we want to do interestingly, I don't know that there's anything that puts the actual name of the entity type into the thing that's spawned. Let's quickly see if there's something in here in LDTK that I'm missing. That's interesting. Maybe we can use this. No, that's layer identifiers. Not what we want to do. Okay. So I think what I would like to do is we're going to, oh, I lost the thread there for a second. So when we, let's look over here in the LDTK book. Let's see. Okay. Like here, this is sort of what we're doing with our bundles. We've got the identifier that it is in the editor, pointing to a bundle that we have in our code. What I would like to know, maybe it's in here, is can we take that string and stuff it into a component? Okay, so there's entity instance. We could do something like this. Unless, actually that's not necessary, because if this entity instance remains attached to the thing, even if we're not having it have any behavior, we can always get the identifier there. Okay, so let's see. Let's look at Bevy again. And so if we get an entity, we can remove. You can remove a bundle of components from the entity. Okay, so what we want to do then is right. So if we added something with the enemy prototype, so we're going to go for entity in query dot, and we don't need this to be mute because we're going to do all the mutations via the commands iter. We do into iter. Yeah, let's try that. Okay, so that gives us actual entities. Maybe it still. Yeah, it still doesn't. It doesn't give us references. We don't want references. Okay. So if we say commands.entity entity, and then remove, we can give it, this is a bundle. We can give it a list and returns me itself. Okay, so we can chain it, or we can give it a list of things to remove. Let's look at their example here. Okay, so it's generic over the bundle. So if we would just want to remove it from the world, let's go back to the prelude. Okay, so we can remove the spatial bundle. Yeah, let's just do that and see what blows up. Because if we look at this, what we care about is the sprite sheet bundle contains basically the spatial bundle. And the spatial bundle is just a prototype of what should be in there, which is like transform, global transform, visibility, inherited visibility, view visibility. Right, all those things. Then if we remove the spatial bundle, it'll remove all of those components, but leave the texture atlas sprite and the texture atlas handle. I think that's what we want. Okay. Excuse me. So let's make sure that method doesn't panic. We don't want any ref. We want entity commands. Cool. Not not there. Entity commands. Yeah, okay. So you can remove whatever you want. Before we do anything else, let's make sure that this did not break our program. And real quick, I'm gonna make sure I'm up on the latest Rust stable, and then we'll build and run the project. Hope you all are enjoying and following so far. I know this is a lot of me just kind of musing about what we might be able to do, but we'll get there, and I think that this will be a nice outcome, and we can start building other levels with data in LDTK. So after we get this, the enemy prototypes, their spatial bundles removed, then we can look into how do we create another one from that prototype. So, okay, let's cargo build. It's got to rebuild everything. Well, that's going to ditch my gum. Yeah, so after we get this, we'll maybe make a test thing, a test system where we'll just try to get one of the prototypes, clone the relevant data out of it, and then add the spatial bundle back and position it in the world. If we can get that far, then the next step will be look at the LDTK level metadata and go through the list of enemy types and spawn them on our timer like we did before. And we can use some of the same logic to spawn them inside the world, or inside the level rather. Now, what I don't want to see when we run this is that removing the spatial bundle makes the whole thing crash. That would be bad. I think what will happen is that if I have an idea of how Bevy works internally, which I'm very vague right now, but there will be a system that will look for things with spatial bundles, and those will be things that get extracted into the render world. If they don't have a spatial bundle, there's nothing to render. So let's run and see what happens. Okay, so I'm going to go to the top left corner where our enemies were and make sure they're not over there. Yeah, so they're not there. We didn't crash. I think we achieved what we wanted to with that change. So now let's do okay. Okay, so now let's make a system. And we're gonna add it to this set because this is when we would want to spawn. Let's say spawn enemy, and we're going to not do this, but we'll want some of the same things. And let's start with it more simply. We're going to need a commands object, and we're going to need the spawn timer. And we're going to need the time. And then we're going to need a query. And I'm not sure everything that's going to be needed in it yet, but we're going to need enemy prototype. I think we determined that we need the entity instance because we want to get just the data out of that thing about like what name is it, right? And then later we'll look at, can we get the player and the spawn locations and stuff like that. But let's just focus on trying to get a copy of one enemy, and maybe we'll just put it in the middle of the world regardless, to start. Okay, so what we're going to do, let's do I think we're going to need the entity ID. Let's look at, we're looking at the entity commands, right? So you can add, okay, so that gives an entity world mute. Okay. Let's look, oops, let's look back at commands, because maybe there's a way. I don't think that's what I want. So what I would like to do is, without enumerating everything that's in here, I would like to be able to copy it into the new entity. Let's see if there's anything in like the world, or let's look at world. Move system, run system. I'm not sure what this archetypes thing does. It feels like this is the pattern of what the components are in a particular entity, but it's not clear to me that you can get You can get the archetype for a particular entity, but I don't know that you can get those components directly. And of course, even if you could, they'd be of different types. Let's see. There's this entity ref thing, which I was looking at earlier. Again, this is like, you know, has the archetype on it. You can get components, individual components, if you know what they are. This is why I was saying earlier we might need to just hard code this for now. Knowing what components are needed in there. This is vec component info. Metadata for a type of component resource stored in a specific world. So you could get inspect entity, returns the components of an entity through component info, ID, so I saw this spawn empty on commands as well, or entity commands. Okay, so this is going to be pseudocode. But what I would love to do is go, you know, commands.entity, and, you know, like clone or something like that, or clone components. And that have that give a new entity back with the same components, and then I could remove the things I don't care about and add ones that I do care about. But I'm not certain that we can do that. At least not easily. Okay. So let's not. Here's what we'll do. We will we know everything that is in this. So for lack of you know, a better option, let's make the movement bundle is a bundle. Let's make a prototype bundle here, and it's actually not even that. It's just going to be a type alias, and I'm going to split down so I can see. So what we want here is I don't know if we're going to need a lifetime yet. Let's find out. So we're going to need a collider, and we're going to need collision damage, and we're going to need health, and movement bundle, if I recall correctly, only has velocity in it. Velocity and facing. Okay. Facing has a default. Honestly, those we don't care about. Um, we'll insert those. Which means I think we can remove this because since this is just a prototype, we don't care about movement right now. But we had the Sprite Sheet bundle open. The other thing we need is Texture Atlas Sprite. And handle to, I guess that's a reference. Handle to Texture Atlas. Okay. And it's not complaining about lifetimes there. So what we can do here is do prototype. And since, you know, tuples of component types implement this world query thing, and it's like each item in this tuple has to implement it, then you can put a nested tuple, and we can just use this for now to get that information out. And we don't have a closer. There we go. Okay. And let's reformat. Okay. So we're only getting out of here the things we care about. I will need to make sure that all of these components. Oh yeah, yeah, we're gonna have to do like so. Because you can't have references without a lifetime in a type, and then we'll go tick underscore. Okay. So what we will, I guess then we don't need the entity ID, but we do want that entity instance. And maybe even we'll do move this into here. And we'll do prototype tick like so. And the compiler likes it, so I think we're okay there. This, by the way, is one thing I was trying to think of in a previous stream where like you can define your own query types. And I was thinking, oh, you make a struct and you put the things in it, but you know, if you can just make a tuple full of references, I suppose we could do this with a struct as well. Maybe if we have the opportunity, we'll make that cleaner. This, at least as a tuple, already implements that the necessary trait, so we don't have to do anything for that. So if we go down here to query, you can see the type on this first type parameter has to be world query. And I don't know that there's a derive for this, but it's already implemented for a bunch of things. So you know, component references world query tuples. So if every element of a tuple implements world query, component filters, the with and without, change detection, you know, entities, options, any of ref. So there's a lot of things that are already there. I guess we could do this. Yeah, that might actually be really interesting to do instead. Okay, so they're saying it should be static. We're in our tuple type alias. We're not specifying static. We're just saying it could be any. But yeah, we could do something like this if this gets to be too much. Or if we're like, what's field 0 versus field 5? So. Okay. Let's undo the split here. And we'll start coding this system. Okay, so we're going to do the typical dance of, we're going to do timer dot tick. What is it, tick? Spawn timer. Oh, timer dot zero dot tick, and we give it time dot delta. And we can combine these. Just finished. We can get rid of that. Okay, so we're going to start with not worrying about that data that we put into the level definition. We're just going to spawn ghosts. And then we'll move on to the other things. Okay, so we're going to iterate over the query. And here we can actually destructure. We'll say instance, collider, collision damage, health, we'll call it Sprite, and Atlas. Okay, and then we'll say if instance dot identifier, if that equals ghost, then we're going to do commands Okay, so let's do commands dot spawn, and actually to make this easier, you know, we had originally this bundle. Let's copy that and make an enemy bundle, and it's basically the same stuff. But and we'll remove this LDTK entity thing. We don't need that on there. But it's going to have enemy, and then we'll have this sprite sheet bundle, and then we can get rid of all of this stuff. Because we're not pulling that from the editor. We'll say movement is movement bundle, like we had before. Okay. And now we can do spawn, and we'll say enemy bundle, and let's fill out the struct fields. Okay, so enemy and sprite is going to be sprite sheet bundle, and our sprite, let's see, this is the texture atlas sprite, right? Yep, sprite.clone. Texture atlas is atlas.clone. And then we're going to do, we're going to fill the rest with default. And we'll worry about filling in the spawn location later. I just want to get it spawning on an interval in the middle of the screen. Okay, so then we're going to do collider.clone, and we'll do damage, collision damage. No, come on. And we'll make sure that all those things are cloned. They should be. And this will be default. I'm not interested in promotions, thank you. Okay, so now what's wrong? Oh yeah, we gotta put a semicolon there. Okay, so don't use comma after that. Okay, so these two things do not implement clone. That's easy to fix. go to type definition. And they honestly should. There's no reason not to. And this is so small that can implement copy. And let's go back here. Health does not. That should not probably implement copy. I suppose it could. We'll just do clone for now. It's fine. Okay. And go to type definition. What is it complaining about now? It implements copy so you don't have to clone it. Well, fine. Maybe there's something more we'll want in here later, and so we'll remove the copy. Okay, so this isn't too bad. Just to review, we're checking, did the spawn timer tick over? If it did, then we're going to find the prototype entity that has this entity instance on it, where the identifier is ghost. And then we're going to take each of those related components from that prototype and spawn a new entity, which is an enemy and not an enemy prototype. And then put the sprite and the texture atlas into that sprite sheet bundle that it needs for that. Clone the collider, collision damage, health, and give it default movement bundle. And we can work on restoring some of this logic later. But let's see if this works. If so, like, I feel like we've kind of, again, leapfrogged another particular problem that we had previously. So we can continue to use the editor to define things. And I think that we should probably, I'm not seeing it. So let's put an info statement in here, spawning a ghost. And let's run that again. And we should see it in the yeah, so that's not working. Okay, let's see, found prototype, enemy prototype of, and then we'll say instance dot identifier, because there could be multiple problems here. Let's see if we can figure this out. Okay, I'm not sure that it's even running this system. It is very possible that we did not add it to the list of systems to run. No, we did. Okay, so spawn timer, right? Let's just do that. We're not going to print out everything. Every time it's called, because that could be multiple times a second. Okay, so it's ticking the spawn timer. It's not finding anything in the query. All right, you know, Clippy's going to complain at me, but I'm actually just a little bit paranoid here. Let's that directly in here, and that's not how you do it. How to, yeah, like so. Okay. I'm learning new things in Z every week. Okay, so let's try this. Okay, let's simplify this query. I suspect that there's nothing, what's happening is there's nothing that matches this. So let's start with just like the entity instance. And then we'll do that. And we'll info found ghost. I know this is dumb. I'm sorry, printf debugging. What's wrong there? Unused parens. Yeah, but the type... fine. We need a comma there. That feels like Python. Okay, so it's not even finding these anymore. So I think there's something wrong with... Yeah. I think probably what's happening is this is not attached to anything that has this. So we might need to let's look at that. Okay, let's see what they say about a blueprint pattern. Okay, so they're saying using a simple component or a marker component for the initial spawn and processing it further in another system is called the blueprint pattern. Right, okay. Excuse me. Let's start at the top of this page and scan down one more time. Okay, so it doesn't get very far if you cannot play them. Okay, so gameplay objects on entity layers. We know about those. Anchored layers apply a categorization. Fundamentals associate the LDTK entities anchored tiles with Bevy entities components. Okay. Let's see. Registration API allows you to hook custom Bevy bundles in the level spawning process. So we're already doing this. We're already literally doing that. Okay, and if you go to this trait, okay, so here's the trait. Spawning. After implementing this trait on a bundle, you can register it to spawn automatically for a given identifier. Yeah, okay. Common cases you want to use derive macro, but you can always provide custom implementation. We might go to that. We'll see. Here's the attributes documented. I actually wish that the macro would link to this page, but it doesn't. Macro documentation doesn't. Okay, so we're using Sprite sheet bundle. Worldly, we don't care about grid chords. Okay, so this is about bundling entities. So you can have them nested. Okay, so this is like you registered a dagger weapon, and it has a weapon bundle embedded, which has an entity identifier, or is associated with an entity. And that'll call the other thing we could do, rather than relying on, let's do this. We're going to put a string in there, and then we're going to do like we did for the other thing, from entity instance. Because I think what's happening is this entity instance we're going to say self value.identifier.clone. What's wrong there? It's probably somewhere else in the code. Yeah, because I think that this is not associated with the enemy prototype. Like, it's dropped after the thing is added to the world. So what we should be doing here is this, and get rid of this okay, and then let's try this. Okay, so it is, okay, so now we're actually iterating over the right things. This is one thing I didn't understand. There's that load phase, and the entities that are created from the LDTK data are different than the ones, than the actual LDTK data, if that makes sense. So like that or that entity instance is not the same as the thing that's created in the world that is your game object. So we can bring all this stuff back, and we can get rid of this info, and let's get rid of this info, and then let's uncomment this, and I need to put all this stuff back. So we have the prototype, we have collider, we have collision damage, we have health, we have, what do I call it, Sprite, and we have Atlas. Okay, so now let's try that one more time. Okay. Let's leave this in there and say spawning ghost. And I think there's a layering issue here. So say from XYZ, and 0, 0, and then we need something higher than 0, I think. We were doing that previously. What were we doing? Now we're just adding. Okay, well let's the default should be the origin on that, but let's just give it a transform that we know about, and so we can see if it's they're spawning ghosts, but I'm not seeing them. I have an idea. Let's enable this thing where we were drawing the bounding boxes. I don't remember how we were turning that on. Yeah, let's go down to that system and look. Yeah, okay. So let's features gizmos. Maybe we can see the bounding box for the enemy. Nope. The other possibility is that actual origin is down here based on how the LDTK thing worked. And they're just, nope. Oh, what's this? Does that not look like enemies stuck outside the world? It does. It does. Okay. All right, let's put it at my guess of where the middle is. Yep, okay. So now the problem was I wasn't getting a valid spot for them to be spawned in, but they're also not moving. Okay, we're going to run that without gizmos because that was really distracting. Okay, so maybe we'll do, for now, we'll do a little bit of perturbation. Nope. Okay, let's be a little bit more principled about this and look at this code that we had commented out before. The other thing that we could do is, well, no, that's not going to work. I was going to say we could use these functions from LDTK, Bevy CS LDTK that were giving us conversions between grid coordinates and translations. This is kind of complicated logic. Okay, so let's look at this logic real quick and see what we were doing. Okay, so if the spawn timer finished, this is what we're very similar to what we're doing right now. We're getting the LDTK data and the spawn location. So if we have the project and the level, we had a different, I think it's over in this levels module, where we created this spawn locations object, which was basically here. Let's. Yeah, it's not going to show. It's a hash map of a string to a hash set of grid coordinates. So okay. So then we were getting the grid size, so we can compute, how big each square in the level definition is. And then we're finding the player, so that we can spawn a specific distance and direction from the player. And then we use that as the center. So we're getting grid coordinates for that location of where the player is, the closest grid coordinates. And then we, up to 5 times, we attempt to find an unoccupied tile to spawn the ghost in. So we're using, the thread RNG from the RAND crate. We generate an angle between 0 and tau, which is 2 pi. And then we create a vector on that angle, a unit vector. And then we project that onto the unit square. And so, okay, so this is saying the spawn spot is going to be, in that on that unit square, but scaled up by the grid size, which is 16 pixels, and then also 16 grid cells away. So this is how we were going to get something spawning on a square around the player. And then we translate that into the grid coordinates. So we translate this kind of relative spot into actual coordinates, grid coordinates, given the grid size and the spot, and add the origin. So we've computed where the player is, and we add that offset to that player location, and then we turn that into the grid coords object. So of course, clamping it to between 0 and the width of the level and 0 and the height of the level, right? Okay, and then we use this. Right. Okay. So this spawn locations thing is indexed. This string is actually the ID of the level given by LDTK. And so we say, does the spawn locations for this level contain this coordinates? If it does, then we spawn the enemy in that spot. And right, and so this is turning into a translation. And now we used to have this ghost bundle thing. It's no longer there. And then the direction, this is the direction for where the enemy should be heading. It's heading toward the player. And although we don't actually need that, it should get run every time that this system gets updated. So okay, so the main complication here is I don't know if I'm ready to be doing all that. Maybe what we can do is factor this, pick a spot out into a different function from what to spawn. And we would still need to be able to pass in all this stuff. which will make this particular thing kind of not pretty. um, but really all we're needing is this based on all of this logic. So we should be able to break this down into multiple pieces. Before we do all that, let me run it one more time. And I want to see it without the gizmos and see if the ghosts are actually moving. Now they are turning. You can see that because we have that logic that flips their facing direction. But for some reason they're stuck. Which is not good. And I'm not sure what they're colliding with. Okay. So let's see if we can get, we had this type here. Maybe let's make a derive role query struct on that. Struct enemy prototype query. Derive world query. And then we're going to say this is going to be prototype is enemy prototype. And let's look at the docs for that real quick. Wrong one. Okay, so these all have to be tick static references. Okay, so then we can do, so we derived world query on that. We can do, and I think we can just use enemy prototype query. We don't have to put references on it. Because I would hate to have double references. Yeah, you don't put references on it. And this will hopefully keep us from needing to put the clippy complicated types ignore on there. But we'll find out. And here we can do enemy prototype query and do like so. Hopefully without changing any of that. Okay, well, let's just call it prototype, and then we'll put in all the things that we need. .spawn, or .sprite.clone, prototype.atlas.clone. Okay. So now we need some of this stuff. Let's, do we need the level selection? Yes, we do. Okay, so let's get this relevant stuff into our arguments to this. We need that. We need that. Okay, and I'm going to rename this prototypes. Okay, so we got the level selection, got the projects, got the assets, got the player, got the spawn locations. And then what I want to do is, without, I just want to like have a function called is pick location, and we're going to pass level selection and LDTK projects, and then we can just modify that other commented out function, project assets and player to that. And oh yeah, and spawn locations. And then we don't have to bother with this. We just say transform. So we're going to change this to, we don't need the timer stuff. We're going to change this to pick location. We may still need that clippy too many arguments. We'll find out. And let's uncomment this stuff and start getting to work. Okay, so I think most of this we'll just get rid of the timer because we're not using the timer here, which means we get rid of those two. And we're missing one. Okay, so here we're going to do spawn spot grid. Okay, so we need to, yeah, import. We're gonna have to fix a bunch of those. We're not going to do that. We're just going to return spawn spot. And then if the other thing we could do here is have it return an option. Okay, so this is going to, yeah, let's, okay, so this can return an option of translation or transform. Is that what that returns? No, that returns a vec2. So let's just have it be a, I think I want to bring, yeah, no, that's fine. Option vec2. Let's just say option vec2, and then we'll figure out how to convert it to a transform later. And then if we fall out of this, we'll return none, and that'll just clue to this other system that we'll say let some spot else return, and we won't spawn anything. And the other thing we can do here is let's leave it. Okay, so we need transform from translation, and we'll do spot.extend 0. And let. Okay. And let's fix that. Let's see what else is broken. Import that. Import rand.rng. Okay. Okay. Well, that's wrong here. Let's rename this to pick spawn location. Okay. I don't know why it's complaining about that. Consider changing this parameter to type in function pick spawn and to borrow instead of owning the value isn't necessary. Oh, and this is the issue of okay. So let's do this outside the loop. Then it's not expected that it'll be used more than once. Yeah, now it's declippy too many arguments. I don't know a way around that because there are some disjoint queries in here. I don't know that you can combine resources. Yeah, let's look at the resource documentation. I'm not sure that you can like you can for components. I don't know that you can wrap resources, multiple distinct resources inside tuples and still get the same thing. Yeah. Yeah, because this is just a handle, a reference to the resource. Yeah. Okay. Well, we have to put that on there. I don't know any way around it. Allow Clippy. Too many arguments. It is possible that what's going on here is that we need to split this up or something. But yeah. All right, let's see if this works. And here I'm gonna remove that info line. And we're gonna say couldn't spawn an enemy in after 5 attempts. Okay, so we're clearly not doing something correctly. Let's try for the transform. Let's put it at 100 or something, so it's above anything. That shouldn't be necessary, but I just want to be sure. Yeah. Okay, now they're spawning, but they're stuck. And I think the answer is that I didn't account for the movement bundle. And I think I need to put that back in there because it captures the speed. That's why they're not moving. Yeah, because we allow them to move at different speeds. And so let's put that in here as well. let's say velocity. Is it velocity? Yep. Velocity and facing. I don't think we need, let's see. Yeah, let's basically do what we do here. Okay, so we're gonna do, rather than default, we're gonna say movement bundle, and we're gonna say velocity is prototype dot velocity dot clone, and then default. And that needs to be velocity, not movement. Velocity doesn't implement clone. Implement clone when you can, kids. Yeah, there's no reason this doesn't implement clone, or even copy for that matter, but we'll do clone. And this should implement clone as well, although we're not using it. Okay, so now they should be able to move. It was that I wasn't copying the speed that they were. Yeah, look at them go. Okay. Okay, so now we are randomly spawning enemies as we expected to. Let's try to get up to an edge. Oop, almost ran into guys. Let's get up to an edge, make sure they're not spawning outside the level. Yep, it's still finding spots to spawn them in. They're not spawning outside the level. We see one spawn kind of near the corner there. We're doing good. We didn't get any warnings about, now there was just one. I suppose that's okay. Okay, pretty good. Honestly, not too bad. I think we need to figure out how to get that data that we put into the editor, right? We put into the level definition. We need to be able to get this into a data structure that we can use. I think that's the next step. But I think this is a good place to make a commit. Not the cleanest. Let me get past all the editor. Wow, okay, let's just do of source. Okay, so I don't remember what session this was. Does anyone remember? Okay, we did session 15 last time. I could have looked at my git log for that. Yeah. Okay. Okay, so we're in session 16. And we're going to say restore random spawns using enemy entities as prototypes rather than instances. Okay. So now that we've got that established, what we can do is start to look at the data. And similar to what we did in the spawn locations, um, let's we're going to need something like this. Um, let's just call it spawns. Derive resource default debug. Okay. Spawns. And this is going to be a hash map because it has to be, remember, for a particular level of a string, a vec of item string, and I don't remember how it represents numbers, integers here, how they're going to come out. So we'll figure it out, I think. Let's just say it's a U64 for now, and we'll come back and adjust that as needed. And that needs to be like so. Okay. And let's do something like this. Except it's going to be not hash set, it's going to be vec string U64. Okay. And this is going to be spawns. Let's make what I want to do is as we spawn a level, we'll copy, we'll clone this vec, because this is just data that's coming from the editor, right? We'll copy this data out into a new resource. And it'll be active spawn list or something like that. And it'll be, it'll be that. Okay, and then what we can do is make a pop spawn, or yeah. And we'll say this takes mute self. And this will return an option of stir. And here what we'll do is we'll say what we want to do is look at the head of the vec. Can you shrink down a little bit? Okay. The other thing is we could start in reverse order, potentially. But what I want to do is get the, and this is probably on slice, not on vec, and it's going to deref as slice. So what I'm going to do is first mute. Okay. So, we're going to have some interesting boundary conditions here to deal with. But basically, what I want to do is look at the first thing on the list. If that U64 is greater than 0, then we'll decrement it and return, a reference to the string. Yeah, so let's do that first. Okay, so we'll say if let sum name and count. First mute. Otherwise, we're just going to return none because there's nothing left in the spawns, right? I'm not sure this is the best structure, but maybe a vecdeck would be better. The other possibility, and this feels kind of silly, is that rather than having this list of pairs, we actually just have a list of the entities and we just pop them. That would be the simplest. It's going to consume more RAM because we're having a bunch of strings in there. Now we could potentially find a way to do, as long as the strings are static, we can like box leak them or something. I don't know. Let's try this way first. Okay, so that's let's see. Count is oh wait, I want to split first mute. I just want first mute. Okay. So name is mute string. All I want to do is as ref here. Okay. Returns referencing data owned by the current function. Okay. So now we'll say, so if count greater than 0, then we'll do this. And this is where it's starting to feel a little bit eh. We see count minus equals 1. And that's probably star count minus equals 1. And then the other thing, I guess we could recurse and we could say self.0.remove 0 self.pop spawn. Okay. So here we've got multiple issues. I think I need to treat these separately rather than trying to. Because I've got overlapping borrows here. This is just bad code. That's the essence of what I want to do, though. So let's try to rework this. Okay. So if we say if self dot zero dot len is or not, when we say if self dot zero dot is empty, we'll return none. Okay. So then we take care of that case first. Yeah, except like that it's still going to require us to do if let. Now what we could do is go let name count and borrow it immutably, because what we don't want to do is I don't want to have overlapping borrows. So we'll say there, because we know it's not empty, so there's at least one element, so we're not going to panic if we get the first one. Okay, so now we know that it's this name if count is greater than 0. So if we say if count is greater than 0, then we're going to we're eventually return some name as ref. Okay. The problem here is I'm about to have overlapping borrows as well, again. So maybe what I need to do is just say, I'm going to copy that. The other thing we can do here is say, see if we can clone the first element. Like, yeah, let's just do clone, and then we won't. Whoa! Then we won't have that borrow problem. We can still return stir, right? We'll just say none to satisfy the compiler for now. Right, and that's fine. What we're going to do. I thought that cloning would have fixed this. Because what I want to do is if count is greater than 0, I think it's really just, oops. We have to go back to own strings. I kind of didn't want to. Maybe we can fix it later. We'll see name.clone. It's moved there. Let's borrow it. Okay, if count is greater than 0. Okay, so now we're really trying hard to avoid borrow checker problems here. So now if we know that the count is greater than 0, then we know we eventually want to return that is the next thing you spawn, right? What we want to do is say actually we'll do 1 count -1. Now we're still getting overlapping borrows. I mean, we could do mute, and now it's going to be like, and then we'll do, I don't know that this is the right way, but okay, that's fine. Yeah, this is kind of what I wanted to get to. Okay, so if we have, we can return I still would love to return stir. This is a mutable reference to a string. I bet what I have to do is borrow the deref. Yeah, there we go. Okay, that was a little weird. Because it was trying to make another reference of a reference, and that was not right. Okay, so then we have to deal with the problem of if count is 0. Okay, so here, if count is greater than 0, then we know we can decrement it, and we just return the name. If count is 0, which we've already determined that, if we don't have any more, we there are too many invariants I need to enforce here. Okay, I think what we do here is we do I'm actually kind of worried about this mutable borrow getting overlapped, which I think is what we saw in our first version. It's complaining about not returning the right type. Let's just put none here for now. Yeah, and so it's borrowing it mutably twice. Now what we could do, and this is probably better, which honestly means we should be using a vec deck. Not a vec. I'm not worried about these being too big, but I'm just worried about churn. We should pop. So rather than this, we do dot we could do split first mute. It returns the first and all the rest of the elements of the slice, or none if it is empty. So this returns it returns it as a slice, a mutable slice. And the thing is, what about split first? It returns a reference. Yeah, the thing is, maybe I should be trying to do this with slices rather than vex. I mean, because you can deref them as slices. Yeah, unsafe. Now, if we're going off of the end, this gets a little bit less tricky, I feel like. We're treating the first element in the vec as the thing that we want to tweak. It's a little bit less expensive if we're popping off of the back. Because pop takes the last element. The thing is, I want to avoid removing that if we know yeah, this is getting complicated. Mostly because what I want to do is if the count is 0, I want to remove it. Like, it doesn't need to be in there any longer. Now, the other way that we could do it, and this is probably actually better. Let's rethink this. So that was attempt 2, not that different from attempt 1. And we'll wrap up soon. I'm getting tired. So let's instead do we're going to do self dot let's just do a for loop. We'll say for name count and self.0.itermute. Okay, so we only care about if the count is greater than 0, right? And here we're borrowing, string and count. So if count is greater than 0, then we know we need to spawn this. And this is like just mutated in place. And if you get to the end of the vec and there's nothing, then we return none. So none. If the count is greater than 0, we'll say star count minus equals 1, and then we'll return sum star name. Oh my god, that is so much simpler than what I was trying to do. And it came from the fact that I was trying to both like return a useful value and mutate the extent of the vec at the same time. Okay, so what this will mean is, it's not that much data, but if we had like a really long list of different types of enemies to spawn and their counts, then we would be, when we get to these last few, we're going to be looping through everything in the list, which honestly, linear scans, I'm not incredibly concerned about. Compiler's really good at optimizing it. The CPU is going to be like, yeah, that fits in a cache line, thanks. We'll be fine. I was probably overthinking it too much. I was like, oh, you need to pop it off and like not consider it anymore. But if the count is greater than 0, we decrement it and we return that name. And then we're keeping track of that. Okay. Now we might be able to get to how do we get this data out. So we did this, spawn spots thing. We need to do something similar here. So let's do preload spawn lists. Okay. And we're going to need, so where's our plugin? We need to init a resource here. We're going to need spawns. So that's going to be the, hash map of string to this. And then we'll init a resource as well for active spawn list. Okay, so we need to do something like this. And I think that there was so the wall colliders was like when we added we're probably going to need to do similar queries like we did here. Okay. We might not finish this today, which is fine. And we want to do preload spawn lists. Okay, and we're going to do, let's look at the ECS LDTK book real quick, because I think there was something about when a level was selected, you could determine there was a system or an event or something that would run. Let's look here. Okay, so we got LDTK world, level entities, entity layers. So I need to look into where we can get that data. So let's look at the world bundle. And the level set is hash set level LIDs. Okay. What other data can you give me? Okay, level data. Okay, so there's field instances. Potentially. Okay, layer instance maybe has the information. Like what is this? It's the custom fields. Let's see if there's some iter fields. Reflectable fields for the struct, and that's not exactly what we want. Level metadata, perhaps. Not really an example of that. Okay. That's not what I want. That's like some... It's probably this trait. And field value, yeah, field value is... Yeah, so we can get... So ints are I32, so let's go ahead and change our code to that. We don't actually care. I32, and this will be I32. This will be I32. Fine, okay. Okay, so let's get, we'll want a different system for when a level is loaded that we can trigger. So let's start with, we want like the spawn lists. Let's call it that. Res mute, and this probably needs the mute tag on it. Spawn lists or spawns. Let's call it that. Okay, and that's, you know, our hash map of that. And then we're gonna do okay, we're gonna do something similar to this. So we're gonna need the level query. We don't need that. We don't need that because we don't care about the tiles. We just care about we don't want, I don't think we want entity. We want something that will get us, what is this trait implemented on? It doesn't say. Yeah, it doesn't say what implements this. Because what we would like to look at, okay, so here's loaded level, which probably has the information that we care about. Of course, there's some indirection in here because they are distinguishing between the stuff that's actually in the ECS and the data that's loaded off of disk from the JSON file. So it's kind of mixed up in here. Yeah, this anatomy of the world thing. Okay, so level entities with this component, but what other components are on that is what I'm wondering. Levels are selected, and it says the level spawning process begins. Like a level selection. Yeah, you can define your own level set. We don't care. Unfortunately, I paged a lot of this out of my brain. Okay. So let's look real quick. We just reused some of this stuff. So like we had the project, and it has, so there's assets. So like I think that the project data is what one thing that we want to get. Right. So there's a query for handle LDTK project, right? And then we needed the level selection. I suppose the level selection we need for populating the active spawns. But if we get, so there's loaded level. Where does that come from? Okay. Right. So I think we need this. We need the LDTK project assets. We need this in our system. Right. And then I'm not sure if we need that, because I think that was about identifying the parent entity for these things. So we might not need that level query. Let's leave it out for now. Okay, so the thing about this is we're querying on added, and this is about tile metadata was added. And here we're not filtering on that, but we need to do this. I don't know that this is right, but this will say what did I do wrong there? That's what I did wrong. This will say we only load it when, or we only run this system when this LDTK project handle was added to some entity. Okay, so now we can do some of this stuff. So let's do this. Oh. Right, so we're expecting a single project. And this is, we're not trying to get a level. We'll say, was this as standalone gives, right, okay. And then we're not using that yet. So now we need to like look at this project data. Yeah, let's do level map. Just hash map of string, which is the IIDs, right, to the metadata. And what is the level metadata? We're almost there. Level metadata. Does this implement fields? It might actually, this might not actually be what we want. Level indices. No. We want to get the, so here we've got, what have we got? We've got LDTK JSON with metadata. Okay, so let's look back at that. That's a struct LDTK JSON with metadata. All right. I don't think this is telling us anything that we need to know. Okay, this is a JSON schema of files created by the editor. Project settings, array of levels, group of definitions. Okay, so we have, I want to find where that with metadata one. Here it is. Okay, so that's the asset. Level map, maps from IIDs. Okay, so we probably want this. So loaded level. Yeah, so let's do loaded, iter loaded levels, which will give us an iterator of these things. And then we want I feel like we did this in this other one. No. Did we do it in the wall colliders? Maybe that's where we did it. Okay, so this is we added wall tiles. Right, we have enum tags, tile enum tags. Okay. Okay, so we were getting out the tags there. Let's see. Okay, so we go the level query, right? Oh, okay. So right. Okay, so here it was going through the list of this is all about entities, which is why it's not going to work exactly the same for us. But we're going through the levels, and uh, we're we're first we're going through all of the tiles that were added, right? Um, and filling in this entry for like what's the grandparent of this thing, um, and then inserting the grid coordinates of this wall tile into that collection. Um, Collecting the tags that are associated with it. So this is like not exactly what we want to do. I thought it was going to be something like we could look at. Now we could do something, for instance, like this. Loop through the level IIDs and get it out of the project information, because here it's like, you know, get me this level, right? Um, and that returns a loaded level. Now, in contrast, up here we're looping over the loaded levels, so each of the things in there is a loaded level. So we don't necessarily have to query the stuff that's in the ECS for that. We just want to get the metadata off of this thing, which is those fields we attach to it. Now, field instances, is that what we want? Yeah. Okay. Okay. So, okay. So we're going to go. Let's say level to spawns. And this is going to be, I don't know why that has tick error on it. That's kind of weird. Okay, so for this is a loaded level though. So we can go level to spawns. Well, let's get the metadata off of there we want first. So we're gonna say this is, we want to get the strings. Oof. Okay. We'll say names. Names and counts. Right, because we're going to want to zip these together. Let's go back and look at this. So this is a field instance. We're on the loaded level. We want to get the field instances. Field instances. Find. Field instances. Iter. Find. Identifier. And we want this to be enemy types, right? Okay, so that's going to return an option of field instance. Okay, and then we want to do, not that. We want to look at the value. Honestly, let's do find map. And we'll do a similar thing for the counts when we get there. Okay, I'm getting a bit over to the right here. So else none. And we're going to unwrap that because it should be there, or let's do expect and say didn't find enemy types metadata on level. Okay, so if the identifier is equal to enemy types, then we will get the value. Strings, stirs, value, else. Yeah, so if we don't, maybe we'll just continue, right? That's not going to work because we're inside a map. Okay. What's wrong there? Okay, so we'll say some unit for there for now. We're going to actually take this and we want to. It's weird to me that this vec of option with string. God, that's obnoxious. Okay, so we'll do stirs dot clone into iter filter map s if it's there. Like, shouldn't have to do that. Now I could just do map with unwrap there. So we're looping through this vec of the strings, the vec of option of string, and we want to remove the nuns. Okay. And I want this to be a vec of string, and then we'll let the compiler tell me if I did any of that wrong. Okay, so yep, that looks correct. And now we need to do the same for ints. Vec of option of I32, fun. Okay, so we'll do vec of I32, and we're going to do this dance again. Find map and fi. And then we'll do expect didn't find enemy. I think we call it enemy counts. Counts metadata on level. And let's not call it metadata because I think they're using that for a different thing. Let's say field. Okay. And we're going to do a similar thing here. So let's copy and modify that. And this is going to be enemy counts. And this is going to be ints. Okay. Really? LDTK? Come on. Okay. So I'm just a little bit bitter. Bear with me. Okay, so we've got these two custom fields out of the level. Now we're looping through the level. We need to make an entry in our hash map. So we'll say level to spawns, insert level.iid, and then we're going to do names.intoIter zip with counts.intoIter collect. And all of this, okay, so we need to annotate that. This is the vec of string I32. Which we can annotate that up here. Actually, I prefer to annotate it up there. So this will be a hash map of string to vec of string I32. And then we can remove the generic you can remove the turbofish down here. Consider removing the borrow. Okay. Are you going to make me deref stuff now? Borrow it. Okay. Borrow that. Unborrow that. Filter map with an identity function. Well, can you fix it for me? Flatten. All right, what does flatten do on an iterator? On an iterator. Flattens nested structure. Yeah, I guess that would make sense because options are iterators. They yield one element if there's some. They yield no elements if they're none. So that makes a lot more sense. That's actually kind of nice. Okay. So, yeah, replace it with if let. This will clean up our code a little bit. Do the same up here. Oh. Hey, if you work on Zed, thank you for letting the back button on my mouse work like it does in the browser. That's helped me so many times. Okay. So now that's a bit more clear. I was mixing up if and let else, and it got a little messy. Okay, so now we have this collection of things, and what we want to do is say spawns dot 0 equals level to spawns. Right, so this is, you know, a mutable reference to this spawns thing, which has the exact stuff that we're building here. So we're basically just replacing that when the project is added to the ECS. Okay. So now, let's maybe. I feel like I kind of want to pause for the night. Like I said 40 minutes ago that I was feeling tired, and we're still going. I'm kind of motivated to finish this stuff and actually do another system that will run and populate this active spawn list, right? It's not, I don't remember the intricacies of determining which level you're currently looking at. Oh, right, so you get the level selection. What I want to do is run this only when we first load the level, so the level selection is a resource. Oh, yeah. That's a good refactor. Yeah. That's a thank you, Clippy. Yay, Clippy. Okay. So maybe we take this really simply, and we go we just run it on update, and if there are no spawns, because like we only have one level right now. I want to have multiple levels eventually, but da, 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 okay, we're gonna say we'll call this populate active spawns. Because like presumably you'd want something where if you've loaded the world data from LDTK and you could choose a level, you would want the spawns to be the same every time you play that level, even if you just got like going back into it from the menu. And we want to distinguish between in-game data and like world data. Okay, we're gonna make a new system here, and we need the active spawns. This is gonna be res mute, right? Okay. That needs to be in the function head, Sean. Oh, for Pete's sake. Okay. We'll just retype it. Okay. And then we need the spawn lists, and this is going to be res of spawns, and then we need this goop again. Basically we need the level selection, and we need that. Yeah, so let's copy this. And we'll get rid of the level query. I think we don't need that at the moment. Okay, so what we're going to do is, again, do this dance. Okay, and we'll do something similar to this. So, but we're not going to do spawn locations. We're going to say spawn lists. Let sum Okay, so if we don't have any data for this level, we should probably be like, no spawn data for this level, for the selected level. And we should panic, but we're not going to panic in this case. Okay, so if we have that, what we want to do is, let's do a check here. If it's not empty, then we'll return. And I know that's not, let's put it to do in here because that's not failsafe. If the spawns are all 0 after playing a level, or the player died and left some spawns behind, this is an inadequate test. Inadequate test. Okay. We'll come up with something better. Like, because what I really want is for this system to only trigger when the level's changed. And it wasn't clear to me how we could easily detect when it has changed. I'm pretty certain when we went through this tutorial that... Okay, so we need level event spawned. Yeah, okay. This is what we need. Yeah, I wish that were more obvious. Okay. Let's take a step back. Let's do... Let's look at that level event spawned thing. So we need an event reader for level event. Okay. Right, and some of the same stuff. I guess we don't need level selection anymore because we'll be getting it by the ID from here. Okay, so if there's no level events, then we don't care. That's a good way to do it. Level events.read. Okay. And then we'll do if let level event spawned, and we do level ID level event. Okay, and then we can do this stuff. Okay, and then we'll say not level selection, but is it get raw level? Do we care about get raw level? What are they using for that here? We don't actually care. We only care about the... We only care about the level ID. Because we've already processed everything. So we don't need this. Okay, and then if right, and then we'll say active spawns is spawn list .clone. Okay, that feels a lot better than what I was about to do. And here we're gonna do level ID. dot into, no, level ID. We're almost there, folks, I promise. Okay, so we'll say Aster. Okay. Hey, we don't need that. Yay. Which I guess means we don't need this either. Okay, so that's really good. And we don't have to worry about is it the correct time to do it, because we're only doing it when a level is spawned. Okay. And yeah. Now, I really do want to finish this. Okay. So we could say here what we could do just for safety is just put an empty vec in there. That way, you know, nothing happens, but you can still load the level, and we'll warn about it. Okay. And now over here, we need to pick. So what we were doing before is looping through all the prototypes. And what we need to do is we need to get spawns, resmute of active spawn list. Yep. Okay. And then we need to go let sum ID spawn ID spawns dot pop spawn else return. So we're trying to get, so this should be a stir, right? And then we can just say if it equals spawn ID. We did all that work just to add a few lines to this system. So now, if I didn't completely mess it up, what should happen is we define this data, it's zipped together, so we have pairs of ghost 50, bat 50, spider 50, cyclops 10, crab 5. Okay, and now we could mix and match those orders and whatever, but we have those fields on the level. Make sure that's all saved, and then when we might go ahead and in this, let's do an info setting active spawn list for level and we'll do something similar up here and go like let's see, collected names counts or got spawns for Okay, I just want to give us a little bit of debug info before we go into this. I'm not 100% confident. It feels pretty good. I don't like this very much. We could maybe improve upon that later. Um, but we should be able to get that data there, and I want to see it happening. Okay, so here's the moment of truth. Oh, I'm never calling that. So let's see, populate active spawns. Right. I never called that system. Okay, so we panicked on preload spawn lists. Okay, so we tried to access that resource on the wrong thread. So it was in preload. What? It's not telling me. Oh, line 119. Okay. Yeah, I think maybe what is wrong here is this, and I need to look and see if there's any other events in there. Because we were doing this system is guaranteed to run later because it's already added this tile metadata component. That's why that one worked. I'm thinking what happens is, you know, we're loading levels and we're trying to run this when the world hasn't loaded yet. So I think this filter is not sufficient. Let's see if there's any other events that are available here. Event. So there's level event. That's not what we want. Excuse me. And I think waiting on the level or the world bundle or this, which is part of the world bundle, is not the right time. It's too early. We could do added on this. Yeah, let's do levels. And then what we'll do is, rather than doing this, we'll do for level in levels dot iter. And that way, yeah, okay. So that way we'll take this, and rather than like replacing the entirety of this like we could in the other one, we'll just insert. So we need to get the level, and we don't need the project. We need get loaded level by ID, and that's going to be, what does that take? It takes a string. It is so weird to me that they have borrow of a string instead of stir on this method signature. That is really weird. So I have to do this goop. Okay. And then we're gonna unwrap that, or expect loaded level should exist. Okay. So then when we get down here, let's not do this. We will just do, let's move this insert onto spawns.0 and get that up there, because we don't need to build the whole thing. We just need to insert the ones that were added. Okay. I don't know if this is going to solve our problem, but let's try. Okay, what do we get? No spawn data for the cycle level. Okay, so we have a race here. We got the correct data out, right? But our level spawned and it ran before we got the preloaded data. We could combine these two things and just not have this preloaded stuff. Let's do that. I like that idea. And then it's done on demand. Not the greatest, but I don't know that we're getting any benefit of caching that stuff. Okay. The downside is we're going to need this stuff in the down in here. Okay, so let me just not this. Actually want to do let spawn list is that. Pull that out. We don't need to clone it. It can take ownership. Okay. Inline that variable. Okay. So we're going to do okay, so now we need to pull this and we can get rid of that because we don't need that resource any longer. But we need these. Okay. So now what's wrong? What did I do? Oh, right. Like we can get rid of that. We don't need that resource anymore. Okay. We're getting ghosts. See if we can survive long enough to see 50 of them get spawned. And start to see something else. Hey, we've got bats. All right. We did it! We did it! Wow, what a journey. I don't know that this game is even fun yet to play, but we've tackled. I think we've tackled one of the hardest things I've tried to do so far in this development. Again, we're getting the spiders, and it's starting to get challenging because we're running out of space. Oh man, there's so many more things that we can do. We can get out of enemy spawns for a minute, and that will feel really good. Oh, I took some damage there. Ouch. And these Cyclops guys are not going to die. We're already spawning crabs. Oh no, I'm going to die. Might as well just suicide. Okay. Yeah, we've got a race condition there. But this an excellent place to stop. Let's look at the diff real quick. Okay, so collect. Here, we're in session 16 still. Collect the list of enemies to spawn. Excuse me. From the LDTK data. Okay, I'm pushing this all to GitHub. y'all can read it. Thank you for sticking around. If you stuck around this long, I just got motivated. I don't know that I was in flow state, but I was really there, just trying to get it done. So thanks for sticking around. I hope to see you next time. Have a good week.